We're good. All right. I just gave my intro. Signal bias. Again, be here seven plus years, etc. So let me ask you all, who has started building an application and launched an application that looks like this, right? You have a simple app that is backed by one database, but over time, as you are asked to build more functionality, you have more users, you have more scale, etc., you end up using a variety of third-party databases, products, services, and so on to be able to build the functionality that you're asked for your users, right? And so now you're using a search database, a mobile database, another third-party charting component, perhaps a third-party master data hub, and much more, right? And all of these lines that you see here imply some kind of data movement and a lot of effort. And I'm talking about organizational effort, not just effort for the developer, but organizational effort, right? Security, patching, syncing, data governance, and much more, right? And it's not your fault. You were simply asked to do something and deliver something for your users because it's what the business needs, right? So there has to be a better way. There has to be a better way to simplify the stack so you can be more productive and build more functionality and not build glue, not build these lines, right? So that's what we'll talk about today. What are those challenges? How can we help where we are a great fit and where we may not be perhaps the best at it, where there might be some trade-offs and some caveats, but that's okay, right? So what are those challenges? So I think first of all, there's two kinds. There's the application level, and then there's the company-wide, right? So application level is all about delighting your customers, right? With obviously fast response from the database, from queries, right? Be able to search, be able to have a mobile experience the same, whether it's mobile, web, desktop, etc. But then as we zoom out, and by the way, that's where MongoDB really shines. We power customer-facing experiences. We are the new OLTP, right? I was meeting customers earlier today. From my perspective, the new API is GraphQL, the new OLTP is MongoDB, perhaps the new data warehouse is Snowflake, and I think the new ETL is Kafka. That's kind of the stack that we see right now. But as we zoom out, right, let's think about those applications in context of the broader company. And really, the rest of the company needs the data that originates in these applications. So we do need to expose that data to the company, right? It needs to flow. That doesn't mean all the time that we need to make copies of and start replicating it all the time. So let's think about that effort. Let's think about those arrows. What kind of effort are we talking about? What kind of work? Well, there's education work, there's skills, there's learning, right? I think we all know this. Then there's management, meaning more like operations. How do you configure, set up, your own configuration management, Terraform, Kubernetes, etc. Then there is the actual act of moving data, the actual data pipelines, the syncing, the ETLing, the conflict resolution. What about non-functional requirements? Not just scalability and security, but what about like all the new data privacy laws that are coming out? And then finally, data consistency. If you do duplicate data across many places, is that data up to date? Is it stale? By how much? Seconds, minutes, hours, days? And what's the implication to your company when your data is stale, right? So let me ask again, and maybe this is to the audience. How many months does it take to build that MVP that we talked about at the beginning? But then how many additional months does it take to now enhance the application with all the modern functionality that you need? Like when you build an MVP, does it take 1 or 2 months? Usually. How much would it take to add search, mobile, real-time machine learning, and much more? 5, 6 months, right? Exactly, 5, 6 months at least. So there has to be a better way. There has to be a better way to simplify this. So let's talk about how we can help. And you probably saw this in the keynote earlier on, or you may have seen this in some of the other talks. We call this the Atlas Developer Data Platform. I call it the layer cake, right? Which essentially says the JSON document model, which is obviously the core of MongoDB, models all the other data models. And as such, we should be able to give you most, and I like to use the word most here, most of what you need to build the functionality that you're being asked to for your users, right? Now, I'm not going to cover everything here because I'd rather talk about them in the rest of the talk. Let's talk about those application-level workloads. And I like gaming, so let's imagine that we are a gaming studio, or a gaming publisher, actually. We own many gaming studios, which themselves have many gaming titles, and obviously we have millions of players worldwide. So all games and real applications need some kind of pre-aggregated metrics, or rather, we always need to calculate metrics and statistics after the transactional data, right? And obviously at scale, it's simply not performant, not feasible to run these calculations every single time, right? So most of the time what we end up doing is to do pre-aggregation. So there's many ways of doing this. The first one is, I think it's pretty self-explanatory, double writes. Yes, when transaction occurs, you also write to another collection, you can write during a transaction, etc. I think that's pretty self-explanatory. But what about doing this in an asynchronous manner using an event-based trigger, where the transaction takes place, but now you publish that event, and somewhere else in the platform, one or more things respond and do the pre-aggregation, right? And what about if we do this also in a scheduled manner, thinking of gaming, maybe when a match ends, when a quest ends, when an event ends, etc. Right? So now I can run these pre-aggregations, and now my stats will always be ready and up to date as there are changes in my data. So what does Atlas have that can help you here? Atlas has a feature called Atlas Triggers, which is essentially fully managed change streams. And what's great about triggers is that essentially it's fully managed serverless functions that are going to fire based on the CRUD event that you define and the criteria that it has to listen in the data for. For example, I could say, hey, fire when an insert occur on the player collection and the zip code is between this range and that range for some reason, because maybe we're doing a campaign in a geographical area, right? And now go and execute this logic that's perhaps a marketing campaign for those players. So I could literally run and run those triggers and enable and disable them at runtime, and actually run many of them at the same time without any change to your application. That's amazing. Just think about the possibilities of doing that, right? You don't need to implement Kafka, right, to publish the topic and respond to it somewhere else. You can simply do this within Atlas already. And other serverless functions could use our $merge functionality, which lets you then materialize the result into our collection, which is your pre-aggregated metrics. And now, as Andrew mentioned in the keynote, we are in preview, right, with column store indexes that will make it even faster and more optimal to run analytics on that data. And we could also even use time series collections. So you could also pre-aggregate and store into time series-based collections where now your data is optimal and organized by, let's say, player ID, device ID, game ID, and then the rest of the telemetry, right? So all of this is available for you in the platform without any additional products or services that are going to be third-party. Right? It's all in Atlas. What about charts? What about visualization of data? Every user wants to visualize the data that they have access to, and you should provide the functionality to your users too, right? In a game, again, I want to see my leaderboard, my alliance stats, my event stats, and much more. And so with Atlas, we have a service, or rather a product really, called Charts, which lets you visualize data in your clusters. You can build the charts yourself, including doing it programmatically. And the charts are fully managed and obviously optimal for the JSON document model. So all you do is literally link your Atlas cluster, one or more, including a data federation cluster, by the way. Remember the demo from Mike Lynn in the morning in the keynote? You could also build charts off of a federated cluster, which itself gets data from a cluster and from like S3 buckets or even an HTTP endpoint. Now, once you have your charts built, they can be embedded into your web apps and your mobile apps. We give you a permalink that is obviously secure, and that's it, you're done, right? No more third-party sharding components, sending data to the client, making sure it works on all kinds of platforms, etc. It's fully done for you. So you can give your users visualization of data right away. Now, sometimes, you also want these kind of dashboards for internal purposes. And that kind of audience tends to like SQL and SQL-based tools. Atlas is not that is not Atlas. Sorry, that is not Charts. Charts is made for data in your clusters in MongoDB. But you could still give access to report builders or chart builders, data analysts, if they want to. But if not, we do have a SQL connector so they can use Tableau or something else. Now, Charts does update, I think, as low as 1 minute. So if you are building like an online trading application, then you need second level, then perhaps that's not for you. And also, sure, there are things like Tableau that have been doing this for many, many years that have a variety of sharding components and widgets that we may not have. So just be aware of what we have, and if it fits your needs, then great. All right, Now, what about being able to run and provide like real-time recommendations and real-time machine learning against data in your clusters? And I think Andrew mentioned this in the keynote as well. Let's go back to some of the basics of Atlas clusters. All clusters run, of course, a minimum of 3 nodes, right? Those are your transactional nodes. That's what gives you your always-on database in region, cross-region, and cross-cloud. Right? Yes, you can run cross-cloud clusters as well and survive a cloud outage, right? And then, MongoDB has had this since the beginning. We can always add more read replicas, and we can tag them for analytics. And now we can even, that doesn't look that big, but OK. One of those nodes should be bigger. I think this might be another slide. But as Andrew mentioned in the keynote, those nodes could also be of higher tier, more CPU and more RAM. So now I can keep more data in cache, making my queries faster, making it faster for aggregation and for Sparks, right? And besides doing real-time machine learning, also be able to expose that data to perhaps SQL clients, like what we call ecosystem analytics. Someone's using Tableau, someone's using Qlik, someone's using Cosmos or something else. Great. They can get access to the data that is instant in real time, right? There's no duplication of data, no moving it to another SQL database that is kind of like a staging database, none of that. It's all live data against the cluster. Now you see the arrows, right, between those nodes. We think of those arrows as effort, but this is really just replication that Mongo's been doing for more than 10 years, right? Atlas runs, I believe, 2 million plus clusters, like a fleet of clusters. This is obviously battle tested, at scale, right? So this is not work for you. This is just what Atlas does to replicate data between nodes, and that's it. You're done, right? And last, there in the diagram at the bottom is the object storage, which is Atlas Data Lake, right, or Atlas Data Lake Storage, which, yes, you can offload data by a time component. We will store it efficiently in our buckets and still index it so it's still queryable. Obviously not as fast as the data in a cluster, but should still be sufficient for your needs. Okay? So I think I just mentioned all of this, right? Atlas SQL, yes. Oh, actually, let me go back. So we do have 2 SQL connectors. There's BI connector, which has been around for some time. But the way forward is going to be Atlas SQL. Atlas SQL is expected to be more performant. It uses our serverless compute, okay? But right now, both work and both support essentially SQL-based clients. In the bottom there, I do want to mention the read-only views. Yes, you can still create views in MongoDB today as well. Right? There was a time where people would ask us, does MongoDB do joins, do transactions, do you do views? Well, yes, we do now, all those 3. So yes, you can create read-only views, which are done using aggregation framework. Now, again, like I already mentioned this, if your internal customers, I think is the right term there, are used to SQL-based tools and SQL-based databases, they might find that our SQL connectors aren't as fast. And that's, in a way, by nature. We are transforming live data, right? SQL to JSON, JSON to SQL when you query. So that's, sort of the nature of the beast, I guess. And sometimes, they might want to do views themselves in SQL. Ours are done in aggregation framework. So you might need a software engineer to help them or to enable them so they can learn how to run views on their own. And once they do, by the way, they're probably going to like it. It's actually quite easy. All right. So what about search? Everybody wants, well, I don't know about you, but even in my phone, I don't even find the apps anymore because there's so many of them, right? I just scroll down and type 3 letters to find the app I know I'm going to need. And that's it. I search now even in my phone, right? And the same thing is expected in every single application right now, whether it's customer-facing or internal. Everybody wants fuzzy matching and autocomplete when you type, right? Everybody wants some kind of breakdown of the data by facets, different price ratios, different T-shirt sizes, et cetera. And what about geospatial visualization, nearby players, nearby stores, all of that? And obviously, when you find, when you hit search and you are presented with results, you expect those results to be relevant and scored according to who I am, what the website knows about me, and of course, what I actually look for, right? So we're going to need all these features, and we have them, right? Because what we've done, we've brought Lucene, the same 20-year-old search technology that Solr and Elasticsearch use. We brought it into MongoDB Atlas, but we've wrapped it under our API, right? So you as a developer don't need to worry about learning Solr or Elasticsearch or others, replicating data, more drivers, more work. None of that. It looks and feels, and because it actually is, just another feature of the database engine. Okay? We tell you use Lucene because we're open about it, but you don't actually interact with Lucene at all. So yes, we do support all of these: fuzzy search, autocomplete, synonyms, highlighting, custom scoring, and there's some good stuff coming with vector search. Actually, it is in early access right now. However, if you have data in SQL, Oracle, DB2, right, some of those, we cannot search there. Our search is made to search data in an Atlas cluster. Okay, so bring the data into Atlas, or perhaps you might need to use another third-party search engine there. Now, we're really made for application search, meaning searching usually text, not searching logs like Splunk, right, or the Elk stack. Okay, and finally, there are other solutions out there that give you like an embeddable search box, right? It's more like outsourced search, I like to call it that, not us. We give you everything in the database so you can build that search box. Actually, the most work you should be able to do is just that search box, all right? I'm gonna go fast because I have 10 minutes left. What about mobile? So all mobile developers, when we talk to them, they spend most of their time writing conflict resolution, offline syncing, et cetera. Essentially framework logic versus delighting customers. So what we've done, we've acquired Realm, the mobile database, right, widely adopted object database actually, and folded now under our platform and API, so that when you work with Realm in a mobile device, it is representing live data from your Atlas cluster. You can define how it syncs, what are the rules to sync, right? Obviously, it is cross-platform. I think Andrew mentioned some of the frameworks like Kotlin, obviously Swift, and many more. Gives you conflict resolution, and yes, of course, it is built for mobile. It is optimal, right? Do consider that we use the cloud provider's network, so our traffic will flow through AWS, GCP, or Azure. So if you have strict requirements, like if you're in government or if you're a very strict bank, it will flow through the cloud provider's network. So be aware of that as well. Okay, I'm going to go a little faster now. So now we talked about app level. What about company-wide level workloads, right? Now let's step out and think about our internal users. So the first use case here is called Master Data Hub, or we call it single view, right? A single view is when you bring data from many different sources, many different systems actually, that are independent but all represent a subset of the data for a broader entity. Let's say a customer, right? One of our insurance customers, had 70 different systems just to represent customer data. So it was pretty much impossible to understand their customers holistically, right? So they brought it into MongoDB when the schema looks something like this. Now, I do want to mention this, and I'll say it with confidence and conviction. MongoDB is the best, the absolute best at this use case because of the JSON document model, right? You see it here, two databases with multiple table siege, foreign key constraints, and all of that, joining, et cetera. But now data comes together into a single entity, a single JSON document, that now, once it's in Atlas, I can add search to it, I can expose it over GraphQL, and much more, right? And here's what it looks like. So yes, you would have all your source systems. That data flows through some kind of CDC. Perhaps you use Spark or something else. And it goes through a layer first before it actually ends up in the cluster. Why? Well, because those merging rules, right, that matching, the duplication, and so on, is logic that you have to build. Like, that is your responsibility. Why? Because it's your data, it's your logic. How are you going to match the data, right? But we can help you, of course. We've done this many times for financial, for banks, for online games, and so on. But once it's in Atlas, now think about the possibilities of liberating that data, right? Now you can expose that data immediately over Data API, which is a RESTful Data API, or perhaps over GraphQL and much more, right? Actually, speaking of GraphQL, I was at the GraphQL Summit in San Diego a couple of weeks ago, and I was blown away at, one, the adoption of GraphQL, but two, the level of scale that companies are running through GraphQL. If you use Netflix, by the way, everything in the Netflix portal on any platform, everything is GraphQL calls. They run billions of GraphQL calls per day. It was just blown away. So what can you take advantage of? I think I talked about all of this, right, to build the single view. I want to mention the last one, the JSON schema for governance. Most people think MongoDB, is a wild, wild west. You can just write whatever you want. That is true. That is the default. There's no schema governance, but you can add it using JSON schema. So you can define a JSON schema, schema, I guess is the right word, and enforce it on a collection. So you can enforce certain fields, right? Like if I go back here, maybe the first block of fields is going to be enforced, meaning required certain fields and lengths. But the data you see nested, that can flow through. That's what gives you your dynamics in your schema, right? Because now, depending on what the customer does with you in all these different systems, it will obviously have variance, when you bring it together. 5 minutes left, so let me go through. I think I'm fine. Now, do consider that the single view is made really for an application that is going to be running, on that flexible, JSON document model, right? It's more like an application that you would be building, like, for example, a customer portal. But your internal customers may really want like an off-the-shelf MDM, and there are many of those in the marketplace, and that's fine, right? Some companies just want a way to bring the data together, do reports on them, do visual rules to match the data, and so on. That's great. That is out there. If you do buy one of these, most likely it actually uses MongoDB underneath, by the way. One of my customers is a hotel, very nice hotel in Las Vegas. They bought a third-party MDM, and guess what? It uses Mongo under the hood. Now, I'm actually going to skip through this one for now. Well, and yes, actually, I do want to stay here. So this is data. Nope, sorry for that. Yeah, there's one slide missing now. OK, so I'll just talk about this. Sorry. So I want to talk about data science. I want to talk about, first of all, centralized data science, OK? All companies probably today have a data science team that is central, meaning that every business unit feeds data to them, right? And it's their job to produce some kind of innovation from the data. That's great, right? And it liberates the burden of data science from each business unit, OK? However, one of the trade-offs, I guess, is that central data science team doesn't own the data, therefore they're not subject matter experts, and that limits what they can do, what innovation they can actually produce, right? So a newer trend that we see now is data mesh, where every business unit exposes their data and their innovation of that data as a data product, okay? So now we think about this, and if we go back to that diagram where we saw the cluster having transactional nodes, analytical nodes, SQL connectors, and all of that. Now imagine if each business unit is running on one or more Atlas clusters with GraphQL API, data lakes, data federation, and search, and everything we talked about. And now they can produce those data products internally for the company, or even for their end customers or channel partners, right? So MongoDB can really help you if you are building a data mesh architecture in your company, especially if you're now also adopting things like GraphQL. Then perhaps these data products also provide subgraphs for your larger supergraph in your organization. Okay. I'm just going to skip through this slide. So you know what? I'm sorry. These slides are just out of sync. All right. There's not even the Keller Williams story here. Wow, what happened? Wow, OK. So before I want to show you this, I want to talk about Keller Williams. So Keller Williams, obviously a leader in the real estate space, right? They published an article. They also have a podcast recording with us. They use most of what I just talked about. If you search for a property, they're using Atlas Search. If a property changes state, right? It got sold, it got price increase, price drop, etc. They're actually using Atlas data triggers. That's powering notifications for the actual end customers as well as internal processes and much more. The podcast is actually really interesting, and they also spoke at our World Conference in New York this year. Okay, so again, the point of our platform is to turn these expensive arrows, which are effort, data movement, and organizational effort, into an automation that's already built into the platform so that you guys can do what? Delight your customers, right? That's what we're here for, to make you be able to let your customers first so I can be your customer. I want to use your products. Honestly, I do. Okay? And so with that, I'm actually 1 minute, 15 minutes early. So if there are any questions or comments, let's go. This is very strange with everybody having
SIG is actually not his real name. His real name, it's an acronym for super incredible genius. I just came up with that. Does anybody have any questions? Thank you, SIG.
You're right.
So SIG's here all day, but we've got a whole bunch of people all day. And do we have an Ask the Experts session as well?
So I will be, great point, I will be at the Experts from 4 to 5, I think it is, just before the happy hour. So I will be out there.
Yeah, and if you have, if you're shy and you want to talk about something later and he's not available, there's a desk downstairs that you could ask to speak to somebody, an expert, and they could help you understand your workload. Thank you so much. Thank you,
All right, thanks
super
everybody.
incredible genius.